Hey guys, I'm back. I'll be creating a series of videos discussing the topics in Calculus 1. Don't forget to follow my page to be updated on every topic that I'll be posting. Kindly share this video to your children, friends, and brothers and sisters to help them learn calculus. So sit tight and enjoy my engineering códigos, the path of becoming an engineer. Alright, so for today's lessons, we will talk about limits. So before we proceed on solving some problems involving limit, let us define first what is limit. So by definition, we say that the limit of the function f of x is L as x approaches to a, and we can write this in the form limit of the function f of x equals L as x approaches to a, provided that we can make the function f of x as close to L as we want for all x sufficiently close to a from both sides, without actually letting x be a. So ano ba ang ibig sabihin ng definition na ito? Simple. The concept of limit is telling us that we are only interested on the values of x that's sufficiently close to a from both sides. We are not interested on the exact value of the approach value, which is a. Okay? Gets ba? Gets na yan. Alright, so for better understanding, let us go directly to an example. So we have here, find the limit of the function x squared plus 1 as x approaches to 1. So the easiest and the most straightforward way of solving or evaluating a limit is we simply plug the values of x into the equation. So in this case, we plug 1 into the equation and then evaluate the limit. So therefore, the limit of the function x squared plus 1 as x approaches to 1 is simply equal to 2. Simple, right? Alright, so let's have another example. So find the limit of the function x squared plus 4x minus 12 divided by the quantity x squared minus 2x as x approaches to 2. In this case, we cannot directly plug 2 into our equation. As you can see in the denominator, if we are going to plug 2 here, the denominator will become 0. And a fractional function with a 0 denominator is undefined. Therefore, we cannot do that one. So, how are we going to solve this? Simple. All we need to do is manipulate this equation using some algebraic techniques. And then, as we can see here, for this case, the denominator, I have factored out x. And for our numerator, I have converted the expanded form into a factored form. And on how did I do that, you can visit my previous video in which I have mentioned there some shortcut ways in converting a factored form, an expanded form polynomial into a factored form polynomial. Well, going back to the main topic, as we can see here in this function, we can simply eliminate these two terms and reduce our limit function into this form. And as you can see, if we are going to evaluate this limit with 2, this is no longer undefined. So therefore, the limit of the function x squared plus 4x minus 12 divided by x squared minus 2x as x approaches to 2 is simply equal to 4. Right? Very easy. Gets, diba? So that is how we're going to evaluate this case scenario of limit. Now let's have another example. Find the limit of the function g of x as x approaches to 2, where the function g of x is a piecewise function of x squared plus 4x minus 12 all over x squared minus 2x if x is not equal to 2, and 6 if x is equal to 2. By the way, maybe some of you are having difficulty on how to interpret a piecewise function. So this is how we are going to interpret a piecewise function. So, in this case, if we are going to evaluate the function g of x, where x is not equal to 2, that means that we are going to use this function. And if we are going to evaluate the function g of x at x is equal to 2, we will use the function here. Okay, so that's how simple we interpret a piecewise function. Alright, but going back to our main topic, what could be the value of the limit of the function g of x as x approaches to 2? Well, sir, if we're going to plug 2 into the function g of x, just like what we do in the two previous topic or previous example, that means the limit of the function g of x is equal to 6. Is that it? Or maybe we evaluate this one, and then we will have two limits of the function g of x? Well, the answer is no. We will only consider this equation. Sir, why? Simple. This is where the definition of the limit comes in. We have previously mentioned on the definition of limit that we are only interested on the values of x that's sufficiently close to a from both sides, and we are not interested on the exact approach value, where in this case is 2. Therefore, we are not interested in this equation where x is equal to 2. We are only interested on the values of x that is approaching to 2 or besides 2 from both sides. So we will evaluate this limit function only with this function. Okay? Klaro ba? Gets? Syempre, gets na yan, right? So, therefore, evaluating the limit g of x as x approaches to 2 is simply evaluating this function. And if you have observed, this is similar to our previous example. So, evaluating this one will be the same procedure. So, therefore, the limit of the function g of x as x approaches to 2 is simply 4. Okay? So that is how we are going to evaluate this one. So I guess that's all for today, and I hope you learned something on our topic for today, and you have already the grasp of the basic concept of limit.